Welcome everyone to the Agroecology webinar series. Once again, my name is Evelyn Zuniga and I am one of the communications officers for the Agroecology Partnership Project. What is the Agroecology Partnership Project? This project officially started in January 2024 and is funded under the Horizon Europe program. It currently unites the European Commission and 72 partners across 26 member states, associated countries, and third countries. This partnership seeks to support the agriculture sector to meet the targets and challenges from climate change, biodiversity loss, food security and sovereignty, and the environment. The partnership combines the resources of the European Commission and the participating countries to fund advanced research that generates essential knowledge and innovative technologies that closely align with its goals. This is our fourth webinar on the series Agroecology Biodiversity. I'm sorry, I have someone saying that they cannot hear me, but my audio is activated. So I think maybe you can check on your end. It could be. This is the fourth webinar on the Agroecology Biodiversity series. And throughout this series, we have been exploring key practices, challenges, and innovations that contribute to maintaining healthy and productive crops for resilient ecosystems. Just a housekeeping announcement. Please feel free to type your questions in the Q&A section and the chat section that I have enabled for everyone. And I'm going to do my best to address as many questions as I can with the time that we have today. Okay, let's get into it. Today, we're very fortunate to have Dr. Pierre Bonnet, who is currently a researcher at the French Agricultural Research Center for International Development, CIRAD, in France. And allow me 1 second, I need to share my screen. Perfect. Dr. Bonnet research focuses on biodiversity informatics, citizen science, and plant ecology, working at the interface between botany and computer science. He currently coordinates the EU-funded project GUARDEN, which integrates artificial intelligence, deep learning, and Earth observation technologies to develop advanced decision support systems for biodiversity protection. His work is dedicated to providing policymakers and stakeholders with high-resolution data and actionable insights to safeguard critical ecosystems and promote sustainable bio-based value chains. And today, the title of his talk is Safeguarding Biodiversity and Critical Ecosystem Services Across Sectors and Scales, which is the GUARDEN project. Dr. Bonnet, thank you very much for joining us today. We are very grateful that you accepted our invitation, and I'm just gonna stop sharing my screen and so you can start your presentation. Thank you very much.
Thank you very much. Thanks a lot for the invitation and this great opportunity. So I'm glad to introduce you the work that we conduct in the past year. So regarding our initial investment in the design of a citizen science platform working at a global scale, which is named PlantNet, that has contributed to thanks to the development of a new IT solution based on the experience that we acquire within the development of PlantNet, and so which was the GUARDEN EU project. I will also introduce some joint works that we conduct with the Mambo EU project, which is currently running, also funded by the Horizon Europe program. And as you will see, as the main common interest that we have here is our interest to support agroecological practices. I will briefly introduce some realization that we experiment within the context of a Plant Agroeco project, which is a national project that in particular support us to improve the capacities that we have to monitor plant disease at a large taxonomical and geographical scale. So the work that we'll introduce is based on a large network of partners and people, but I want to mention the strong collaboration that I have and that CIRAD have since several years with the National Research Institute in Informatique and Automatique, and in particular Dr. Alexis Joly, who is computer scientist at INRIA and who co-lead a GUARDEN project and PlantNet initiative with me. So our main motivation, initial motivation to invest in the way as we did in the design of new methods for plants monitoring was the interest that we have in order to identify solution to limit the taxonomical bottleneck, which is a current limitation that have the humanity to easily identify and record plant species in the world. And so this bottleneck is a strong and huge limitation to allow us to know where species occur, where they are progress, what are their phenological dynamic, and to evaluate the impact of human practices on the distribution of this plant diversity. So this in particular supports the EU strategy, the global biodiversity framework, and also the recent nature restoration law, in a sense that we need solutions that increase our capacity to monitor the current diversity of plant species at the ground level. And so for that, we have to mobilize civil society. So this is why initially, when we start PlantNet project, we experiment the design of this virtuous circle in which we share multimedia and plant observation that were initially produced by the Scientific Institute at the origin of this initiative. This data has been used to experiment, in particular, AI methods to facilitate plant identification based on image recognition and then plant records. And so we share the results of this research activity in the form of services or tools or methods that has been used by actors of the civil society. And so this virtuous circle has contributed to enrich the volume of plant occurrence that this platform has aggregated. It has contributed to improve the capacity of the AI model that we designed for plant species identification. And in the end, it has also contributed to increase the volume of people, the number of actors that has been engaged in such a large-scale monitoring schema. So initially, when we start a GUARDEN project, so more than 3 years ago now, we already have a quite high visibility thanks to the design of the PlantNet platform and its web and mobile app. So we currently have around 20 million of end users of the mobile application of PlantNet, so which allows to access to the species identification services that we design for plant species identification based on image analysis. And we currently mobilized our infrastructure, analyzed several hundred of thousands of identifications that we received. And so this supports a large community of actors. Some of them are illustrated here, but what we can see is the fact that these services are used globally and they contribute to support many different sectors of activities which require plant records and monitoring services. So the design of the platform is currently quite simple. So when people want to identify plant species, they take an image and then an AI model share them the most probable plant species that are visible in the images. And one of the key elements of the design of this virtuous circle that I mentioned at the beginning is the capacity of these end users to become contributors. So if they create an account, if they accept the license condition, in particular, the fact that they agree to share their data in Creative Commons CC by SR license, They share their observation online with the community of participants who can evaluate the quality of the data shared and collaboratively enrich and validate the data that are shared through the platform. And so all validated data can be used to train the AI model, which allow an improvement of its capacity. And then through the dynamic of this platform, all validated data are shared externally with external platform, national biodiversity portal, or global biodiversity information facility, the GBIF. So we initially start the project with a quite strong capacity to record plant occurrence at the ground level, and the involvement within a GUARDEN and Mambo project has supported us to work at different and complementary scale from individual plant to ecosystem level that I will detail soon. So the design of this platform started quite a long time ago, and so we saw many changes, and we took advantages of new changes in the world. Currently, the fact that we did not imagine 15 years ago the so large increase and mobilization of smartphone in the daily life of people, the fact that they could be so strongly connected with quite high bandwidth that allows to share high quality images that have been improved thanks to the sensor of the smartphone. And so I don't think that people could imagine 15, 20 years ago to be able to generate so high resolution images thanks to the sensors that they have in their pocket. So the design of the platform and the aggregation of the data at global scale has been possible thanks to a very large network of actors that involve research institute, botanical garden, but also NGOs, IT company or private company that are interested to contribute to the design of their service of such services in order to evaluate its performances and adequation with their own workflow. I will mention a few of them later. The fact that and so I insist on the fact that we start quite a long time ago. So the initial PlantNet platform has been designed 15 years ago, and GUARDEN project took advantage of that long activity due to the fact that as we start a long time ago, we had the chance to have a quite high visibility because PlantNet was one of the first mobile app allowing non-experts to use the AI services based on the fact that the app is free. They do not necessarily need to create an account to be used. It has really allowed a large part of the world community interested in plant diversity to take advantage of the services that we offer. And so this visibility has allowed also to have a quite academic visibility, thanks to the fact that we have a partnership with numerous research institutes. We took this opportunity also to submit some proposal, in particular for different challenges. And so we receive, as illustrated on the right, some prize. In particular, in the past 5 years, we invest in the Rainforest X Prize challenges that was dedicated to the design and evaluation of autonomous solution for monitoring of tropical forest biodiversity. And so all the data that are generated through the platform are shared, validated data are shared in the form of dashboard, in particular to describe a plant species. And so currently the platform covers more than 85,000 of plant species at the global level. I just highlight the fact that we started 15 years ago to work on 20 European and Mediterranean tree species in particular. And now, thanks to this virtuous circle, we were able to aggregate the visual occurrence data, phenological data at a taxonomical scale, which is quite enormous, even if we know that it's only a fraction of the world plant diversity. So I mentioned already the fact that we share validated plant occurrence to GBIF, and so we share more than 14 million of occurrence at the world scale, which allow other scientific teams to take advantage of this data and to reuse for their academic study and scientific study. Since a long time, we organize international benchmark. And so I mentioned one of them here, which is the one that we organize since longest time, which is a plant clef, which is an international benchmark in which we share annually data sets that allows any research team to invest and take advantage of the data that we structured and shared, and so that have been aggregated thanks to our network of partners. And so all the scientific team, mainly in computer science, are able to experiment new methods to improve capacity for species identification or species prediction based on environmental data that I will describe soon within the context of another challenges. But plant clef is the first one that we organize in the context of this dynamic, and it has allowed us to learn the fact that in the end, many scientific teams were interested to such challenges. The organization of such international campaign allows to structure a community of actors, to structure a network of academic actors interested to work on a common objectives. And so, as annual evaluation are conducted on the same baseline, the same data sets, it allows a fair comparison and a clear comparison of the different methodology that has been experimented. And so year after year, we experiment challenges dedicated on different, we could say, objectives. And so we initially work on scan of leaves, then we work on noisy data. We conduct confrontation in order to compare AI method and expert knowledge. In the past, we also used, because tropical biodiversity is mainly recorded within herbarium, and so for most species known in the world, we only have visual data that are digitized specimen. We experiment solution on that. Some years ago, we work at a global scale, and since 3 years now, the challenge plant clef that we organize is dedicated to conduct multi-species identification. So to not only allow the identification of individual plant organs, but to experiment solution that potentially allows the botanical survey based on such high resolution images of plant community. Here is some pattern in the statistic around the use of the full PlantNet platform, in particular the number of people who create an account. And so we share the result of our work in different way, and in particular we allow the free usage of the PlantNet API in order to allow a large network of people to embed it in their own workflow, in their own mobile application, in their own infrastructure. So the idea of the sharing of such services in the form of an API really increase the reuse of the services that we offer to the community, which can be, as you can see here, some private and large companies, some startup, but also some research institute who are interested to progress together on different subjects. So within the context of GUARDEN, we invest on several subjects in order to improve capacity of PlantNet platform. In particular, we allow its use at the global scale, thanks to the use of 2 international standards, one which is shared by the Kew Botanical Garden, which is a world plant checklist that they share and curate regularly. And the second standard is World Geographical Schema for plant distribution that allow to divide the globe in region that align political and geographical feature. And so this improvement also support us in the implementation of plant community species identification services on which we work and which illustrated here. So once again, when we want to work on a high resolution images, we have to find a solution to take advantage of this huge number of pixels within an images. And for that, we experiment several methods, and one of them, which was the most fruitful within the context of the plant cleft challenges, was a tiling approach. So we subdivide on high resolution images in a small tile. We compute and analyze the results obtained at each tiles. Here you have tiles that are generated at one scale only, but you can imagine to have tiles generated at different scale within the images, which allows to capture visual feature, botanical visual feature, and plants that are present within such images at different size within the images. And so this methodology, initially designed to allow analysis of plant quadrats produced on the ground in order to monitor advices within a crop, or to monitor plant vegetation in natural reserve, has also been experimented in two complementary contexts that are illustrated here on the left. So first, on data generated with embedded camera on the roof of car in order to allow the invasive species detection. And so in particular, this have been used in the context of a pilot study for invasive plant species monitoring in Biodiversity Plus pilots. And so data generated across Europe have been analyzed through this process in order to allow early detection of invasive species visible within such images, illustrated on the left, sorry. And another context of evaluation of the same methodology is based on the use of drone data that can allow the coverage of quite large forest surfaces. And the idea here is to conduct forest monitoring thanks to the use of this methodology based on the production of drone data. And so we invest in that initially in the context of the Rainforest X Prize, in the context of the One Forest Vision project, and now we progress on that with some partners in North America, in particular Smithsonian Institute and the University of Montreal. I'll give you some illustration of the result of such methodology transfer here on data produced on embedded camera on car. So here you have a picture produced in the Azores and a correct detection of Gunera tinctoria here on the bottom of the images, on Hydrangea macrophylla here on the both sides of the images, and on the top on an Edicium species. So we can say that this is an easy picture, and so a much more challenging one on a computer vision aspect is that one. And so the system has correctly detected the presence of this Gunera here on the background of the images, and which is the species that is illustrated here with its quite dark green leaves here. And so you can see the potential of such data and services when they are applied on autonomous sensor. I continue briefly with the introduction of the work that we conduct for plant disease identification based on visual analysis within the context of the Plant Agroecology project. This has been in particular conducted with INRAE and the University of Swinburne in Malaysia. Our main investment in that work has been to try to align a visual data set produced around the world on plant disease illustration. And so here you have some illustration of some of these data sets, and each of them has been initially generated thanks to a dedicated objectives. And so one of the main difficulty is alignment of such a visual data set in order to find a common denominator for the pathogen that they illustrate, but also the plant species that they illustrate. So we use for that the EPPO databases, and we align all these data sets thanks to the EPPO classes. We recently published a paper on the large language model that we used to make this alignment, and we illustrated how good can be models that are trained on such large scale visual data sets when they are used together in order to allow the training of a deep learning model for plant disease identification. So the collaboration with Swinburne University in particular allows to implement this workflow in which we create one of the largest visual data sets that mix visual context and textual data that have been generated automatically thanks to the use of large language model. And we invest in the project in order to implement a preliminary version of the plant disease identification services on which we work. And now the PlantNet AI model does not only allow the identification of plant species, but can also be used in order to make plant disease identification through the use of the mobile version of PlantNet or the web version. And the last part of my presentation will be that one. So thanks to our experience in the use of deep learning model, in particular to classify biological entity, 8 years ago, we invest on the potential use of this deep learning model to design a species distribution model in order to predict the presence or absence of species based on geographical analysis. And so we use the plant occurrence data and the environmental parameter, and in particular visual representation of the environmental parameter where a dedicated plant species occur, in order to train a model at a quite large scale, so 10,000 plant species, and allow this model to predict the presence or absence of a given species in a given GPS location. So for each location, we take the environmental information and satellite information available and predict based on this data the presence or absence of the species. So I mentioned initially the plant cleft challenges. And so here it's a declination of another challenges, which is geolife clay, and which is completely dedicated to this task. And so we aggregate the environmental and satellite data illustrated on the bottom of the slide. We share them with any scientific teams interested to participate to the annual geolife cleft challenges that we organize in several years, in order to allow them to train a model and to make prediction for a given test geolocation. And so it allows us to have an annual fair comparison of the diversity of methods and their capacity to conduct such geographical prediction. So this has support the design of the GeoPlantNet tools, which is now available online, and you will see a few screens later after this at the end of this presentation. So we use environmental and satellite data to train a deep learning model, and we use multi-species predictions that we are able to do at the given GPS location, and we infer some biodiversity indicators, and we also infer the EUNIS habitat prediction thanks to the multi-species prediction. And one of the innovation that has been allowed thanks to the investment within GUARDEN was also the design of this plant-BERT large language model, which used plant species lists, and we could say a classical botanical inventory, and predict a potential missing species within this list, or EUNIS habitat that is the most probable for this dedicated plant species community. And so all this investment has allowed to generate the biodiversity indicators maps, species distribution map at high resolution. So we work on a pixel of 5 meter side and continental scale. And so it has allowed, for example, to generate such map. Here, it's a recent map conducted at the European scale that allows to explore EUNIS habitats at level 1 and 2 here when they are combined on the same map. But it also allows to explore individual EUNIS habitats predicted for any European country at level 3. And so here you have an illustration of the EUNIS classification and maps that we generated for Grid Blue Chain. All the data can be downloaded in GeoTIFF, and so you have the URL where data can be uploaded. So this is a free and already available web platform. And the system has been contextualized to several GUARDEN case studies, Mambo case studies for dedicated natural area, natural reserve, or area of interest. Any user can draw or upload a shapefile in order to get an automated analysis based on the predictions that we generated in the area selected by the end users. And in particular, it can be used to compare a different area of interest. So the end users can upload a different shapefile and then take advantage of the analysis that we were able to obtain for each of them in order to compare the plant species list, the number of tree species, the potential number of invasive species, and so on and so on. So I will conclude with this slide, which is a list of project results that GUARDEN has contributed to generated, which is available on the Cordis EU platform and dedicated platform to share Horizon Europe results. And as you can see, PlantNet and GeoPlantNet are only a fraction of them. I could not detail all of them today, but I invite you to explore any of the ones that could be of interest to you. And here is some illustration of the publication that has been used to do this presentation. So thank you very much for your interest, and so I will be happy to respond to any comment if there is. Thanks again.
That's perfect. Thank you. Thank you very much, Pierre. This is a fantastic project. I had the chance myself to look through the tools, and I downloaded the PlantNet, and it works amazingly. And I also went into the GeoPlantNet, and the resolution it's incredible. Like the predictions, it blew my mind. And I have put the tools there in the chat for people to start exploring
Thank you.
as well. So we have a question here from one of the participants. It says, are there any regional or national managing authorities in the Common Agricultural plans using this public data collection tool?
Yes, so we interact with several actors who take advantage of this data. And so I briefly mentioned when I mentioned PlantBert on the slide here, there is the icon of European Vegetation Archive, which is managed by a large community of academic actors across the Europe, and who are in charge of the monitoring schema for different European countries. And so, for example, they currently revised and enrich the botanical surveys that they produced in the past, but they were not linked to an EUNIS habitat classification, and for that they use PlantBert. So they enrich past botanical surveys that have been conducted in order to use them and infer the most probable EUNIS classification for based on PlantBert. I can give you another example here regionally. In south of France, we have the regional entity in charge of the monitoring of the air quality. And so they used plant occurrences that PlantNet generated that we share on a daily basis with them. And they used GeoPlantNet prediction for, I think it's 23 species of interest or 23 taxa of interest, because in the end, it's not only species. In some case, it's some species belonging to a dedicated genus that are known to generate the allergy. And so they used our data in order to produce a daily model regarding the air quality, and in particular, taking advantage of our data to and combine them with a physical sensor distributed in the region in order to estimate the density of pollen in the air for dedicated species. And so they produce a daily map regarding the quality of the air in the region, which are then reused by other actors involved in human health and other domains. So we have a very large number of contexts in which these services has been used. And what is surprising for us is that we did not necessarily design these services for these targeted end users. But what we learn is that if we increase the visibility and accessibility of our results, we will really facilitate its reuse out of the context for which they has been designed.
Yeah, that's very interesting. I never thought what you just mentioned, like I never thought they would use the tool just to see what like plant that can create allergies and the pollen in the air. That's fascinating. We have another question here. It says, "Thank you, this is very inspiring." And they're asking if this is only in France or other part of the world are yet to join. I understand this is global, isn't it?
Uh, Yes, so it's a so the GUARDEN project was initiated mainly with the European consortium. We also have a non-European partners, in particular National University of Madagascar, that has of Antananarivo, based in Madagascar, that has allowed us to evaluate some GUARDEN solution out of the European context. But that's true that we also have a network of partners. I mentioned the University of Montreal, Smithsonian, Institute of Technology in Costa Rica, several National Herbarium in Bolivia, and so on and so on. So the context of the project is really positioned at the global scale, because our initial objective is not only to focus on French or European context, but at the global one, in particular because Europe has this expertise and hosts one of the largest herbarium collection. Thanks to the history of the institution. And so for most tropical country, the knowledge about the plant species record in this country is hosted in a big herbarium collection. And some of the biggest one are in North Central region. So we are concerned by the fact that we have to find a way to share this knowledge at the global scale, not only because it's a fair way to share the work that has been aggregated in the past centuries, but it is also because the field needs in this tropical region really require such knowledge and information that unfortunately are, we could say, in a sense, locked in such collection, because they are so distributed across the institution that it's not easy to have a synthesis, for example, of the real known distribution for a dedicated species of interest in a particular domain. It can be for food production, for human health, and so on and so on.
Great. We have a very interesting question here. It says, I just wonder if you plan to link such a huge amount of plant-related info with soil type and diversity.
So we made a link with soil data through the fact that in the LLM that we used, we also use some rasters that characterize the soil. So we use soil information in order to understand and capture the ecological niche of each species on which we work. But we don't yet use the plant species occurrence that has been produced and that are generated to infer quality of the soil, which has been done, for example, by some partners who use the PlantNet API here. So they are not mentioned here, but one of the application, one of the application that have been developed by some partners, SoilDiag, was dedicated to, so they use the PlantNet identification services in order to allow farmers to identify plant species in a given field. And based on that, they have a matrix that allows them to estimate some characteristic of the soil. And so based on that, they use the plant as a bio indicators of the quality of the environment. So we did not, we could say, personally invest in the design of this solution, but it was one solution that has been experimented by some partners thanks to the services that we offer to them.
Okay, great. Let's take this next question. Can the tool be used to compare biodiversity on arable land compared between conventional and organic and agroecological farms?
It can be used. We did not use for that dedicated question. And what we hope is that the services that we generated will allow people to reuse what we produce for that purpose. So when you use GeoPlantNet, when you create a user account, you can store different area of interest. So you draw the area of interest or you upload shapefile that are area of interest for you. And then you can download the report for this different area. And so this can allow an end users to collect different reports corresponding to different scenario of management for dedicated field, and then compare the the predictions that we are able to conduct for this different area. What is not feasible yet for us, because it was too costly in terms of time and IT resources, is implementation of an annual workflow that allows to make annual prediction in order to monitor potential change related to human practice. So this is what we hope to be able to do in the future. And given the fact that we have the chance to access to some annual global satellite coverage, we could use such data in order to conduct and generate an annual raster for the dedicated species, and then made some prediction for our biodiversity indicators at the annual level, and not static one as it is currently the case based on the past information that we are able to collect.
Okay. I saw one part of the project that was very interesting. It's in the tutorial of GeoPlantNet that it's in YouTube, and I put it there, the link. They talk about like how can you use the tool to, if you're going to do some kind of infrastructure, just to check in which part you should expand. Like if you have like endangered species right here, so you better not touch that piece of land, or maybe you go like to somewhere
Yeah,
else in the land. That was very interesting.
yeah.
We have another question here. It says, does the tool enable longitudinal analysis, for example, variation of plant species over time in a specific space?
And so what we don't have yet is the temporal pattern.
Mm.
So we did some study in order to, and we have a PhD within the team that work on population abundance dynamics based on PlantNet citizen science data. But it is based on the data generated through the network of PlantNet actors, and not thanks to the environmental information that we are able to aggregate annually. So once again, this is on a future objectives, but we were not able to progress enough on this topic, in particular, given the fact that it costs a lot of time to implement the workflow that I illustrate to you and to share that workflow. So it consumes quite a lot of energy and resources to ensure that the work done is well distributed. And so identify the most appropriate way to share the result is quite costly.
Yeah.
So this is why this is where we invest in this preliminary version of GeoPlantNet in particular, instead of working on a regular and annual prediction uh, because of time constraints. Yeah.
Great. I'm gonna finish with this question. So now
Yeah.
that the project has finished, so how would you like to see the tool from Garden, like GeoPlanet or Planet, being used to implement or monitor biodiversity in Europe? Like, what would be the lasting impact that you think that you would like the project to have around the
Mm.
monitoring in Europe or
Yeah.
worldwide?
So the direction that we have now and that are quite clear is the fact that PlantBert is currently used in order to really support EUNIS habitat monitoring at a continental scale. And so we are confident that this result itself alone, we could say, will really support community factors in order to monitor EUNIS classification. Another context of development is linked with EU Joint Research Center. So we have a collaboration with them. We co-supervise the PhD students. And it is clear that there is a clear benefit of the work done in order to complete with the data that they use, in particular the EU Lucas dataset that is that have been initiated since a long time. And so combining complementary source of information in order to have a better picture of the current biodiversity and in order to potentially measure impact of past practices on such a biodiversity is also a clear target. And then a clear and third one that I will mention is the fact that most of actors now invest in the use of autonomous sensor to support their daily work. So it is clear for us that even if it's not yet widely diffused, so the use of drone embedded camera will be probably much more important in the next 5 years. And so this is why we invest in the design of solutions that can potentially automatically analyze quite a large visual data stream that could be generated through, for example, agricultural robots, embedded car on boat, bike, or car, embedded video on a boat, bike, or car, and drone data stream. So this is a clear target, how to adapt our solution to data generated through autonomous sensor.
Okay, that's fantastic. It's fascinating. We have more questions, but we have to close. We are 10 minutes past. Uh,
Okay.
Pierre, thank you very much for joining this fascinating project, and I'm really happy I managed to have you in with us today. And thank you everyone for joining. I'm going to so there's there will be a recording of this webinar. People are asking if the presentation would be available. There will be a recording. I'll put it in the Agroecology YouTube channel. And thank you everyone for attending today. And I'll do another webinar in May. I will just let everyone know in this call when what the webinar is about and when is it going to be. It's going to be in May. And thank you very much, everyone. Thank you very much, Pierre. And have a good
Thanks
day,
a lot.
everyone. Goodbye.
Bye bye.
Bye.